In order to discuss an object that's experiencing periodic motion or motion that repeats itself, there's two terms we're going to have to become familiar with. The first being the period, and the second being the frequency. I'll define both of them for you and give you some quick examples. So, the period of an object's motion um, is represented by a capital letter T. And you can think of that as time because it's a period of time. And the period is just the amount of time required to complete only one cycle, and we measure that unit in seconds. We measure that quantity in seconds. So to look at an example, if the moon takes roughly 27.3 days to complete one cycle around Earth, which it does, the period of that moon's motion is 27.3 days. Again, we typically measure in seconds, so this should be converted. The actual answer would be 2,358,720 seconds if you convert days to seconds. The most important thing to realize here is the amount of time required to complete one cycle. So the period tells us the amount of time for one cycle, and if this period of this moon's motion is very large like that, you would not expect to frequently see the moon several times flipping around the Earth, so therefore the frequency is just the opposite. Frequency is the number of cycles completed in only 1 second of time. It's represented by a lowercase f, and it's measured in a unit that we call hertz. So to look at the same example, the moon takes 27.3 days to complete one cycle around the Earth. We've already found that the period will be 27.3 days, or 2,358,720 seconds, the amount of time for one cycle. We are interested in the opposite, the number of cycles in 1 second. So we're not concerned with one cycle as we are with the period. We're concerned with 1 second because we're dealing with a frequency. So if I take the number of cycles, it completes one cycle in 2,358,720 seconds. So if I divide those two, that tells me that after 1 second has passed, the moon will have completed 4.24 times 10 to the negative ninth hertz, or cycles per second. So 4.24 times 10 to the negative ninth cycles in 1 second, which is only a fraction of its entire cycle. So if we take a look, the period here is very large, 27.3 days. The frequency is very small. And hopefully that makes sense, because if something's taking a very long time to complete one cycle, you would not expect to see it very frequently. So the frequency here is very low. If we look at this a little bit more in depth, as I mentioned, we see here that the period of the moon is 2,358,720 seconds. The frequency of the moon is this very small number, and the higher the period, you'll find the smaller the frequency. Just like if something's coming around much more frequently, you would expect the period to be shorter because you're seeing it so much more frequently as a result of it completing its cycles significantly faster. And this just points out and highlights a pretty fundamental concept that's important to know. You should definitely star it, circle it. This needs to be somewhere in your notes. But the period and the frequency of an object's motion, a repetitive motion, are inverses of one another. The period is quite simply equal to 1 over the frequency, and the frequency is equal to 1 over the period. And again, it goes back to what we stated here. The amount of time for one cycle and the number of cycles in 1 second. So they're really just asking for the opposite. How much time per cycle, how many cycles per time. So it's just the opposite. They're inverses of one another. If I know the frequency, I can find the period using this equation. If I know the period, I can find the frequency. You simply take their inverses. So to show an example of this, to calculate the period, we know that the period is an inverse of the frequency. We also know that it's the amount of time per cycle, so the amount of time for one cycle. So to look at an example here, we have a record player. It spins 18 times over the course of 2 seconds. Well, the period, we could certainly try and use this equation, but we're not given the frequency, so this equation will not help us. But we are given time, and we are given the number of cycles. So we can plug them into this equation. So if we look at the period, my time is 2 seconds, and the number of cycles is 18. I complete 18 cycles in 2 seconds. So if I plug that in, you'll find that I wind up taking about 0.11 second to complete one rotation. So this record player is spinning fairly fast. It only takes about 1/10 of a second to rotate one complete cycle. Now, once I found this, if I wanted to find the frequency, hopefully you remember that they're just inverses. So quite simply, if I want to know the frequency is 1 over the period. If I know the period, which is 0.11, I should be able to plug that in, and the frequency of that record player is 9 hertz. Now, if I look at that same example again, but I look at it from the calculating frequency point of view, you can see here it's the same record. It spins the same number of cycles over the same amount of time, but I'm going to use my frequency calculations here. We're going to pretend that we don't know the period yet, and we already know from this previous example, but I'm going to pretend that none of this is known yet. So if that's not known, I have to go with what I'm given, the number of cycles, 18, and the amount of time. So the frequency is the number of cycles per 1 second. So I'll use my first equation, cycles divided by time. Well, if I can complete 18 cycles in 2 seconds, if I divide those numbers, I find that I can actually complete 9 cycles in 1 second, which is what frequency is, the number of cycles in 1 second using the unit of hertz. So the frequency here is 9 hertz, which you'll see we found before using the period calculation, the inverse relationship. Now I found it using my actual frequency equation. And if I'd like to find the period, again, you just need to realize the period and the frequency are inverses. So if I go ahead and I plug in 1 over the frequency and plug it into my calculator, I will find the period is 0.11 seconds. So 9 hertz, 0.11 seconds. You'll notice that 9 hertz, 0.11 seconds. It will not matter which equations I use. One way I remember the period equation, I think of t, since it's period, t time top. The time goes in the top, the numerator part of the fraction. So t time top, that's one way you can remember it. Or you can just remember that the frequency is the cycles in 1 second of time, so cycles per time, and the period is the time per cycle. It can be a little confusing, but if you can think of a way to remember that, you should have no problem calculating these two quantities, and you'll limit the number of times you confuse frequency with period.